Now, for one of my responsibilities for this project was the deliverables, mainly trying to find and acquire the components for the EMS, mainly finding the LEDs and the sensors and getting that so then we can come together and construct the EMS. Next, I'd be responsible for burning the programming for our EMS onto a CD so then it would be able to run, and everyone that either purchases it or uses it is able to use this device properly. It would run on LabVIEW runtime engine 8.5, which it would need to run with. Next, I would make sure to construct a technical manual. This is just giving the owner or the user an idea of the properties and programs that are in the CD-ROM just to use it. And then the product brochure, I'll also make sure that that is done as well, to have just information on where to find it or where to purchase it and other technical data. And then the specification sheet will ensure that the user would have all the specs and everything that they need to ensure that this is a product they are requiring or needing for their project. Next, for my portion of the project, I would be focusing on methane. Methane is an odorless, colorless, flammable substance. Usually you would see this natural gas in nature, decomposing areas, or landfills, or livestock, which would have that. Methane is explosive, so if it has a certain percentage of volume in a given area, it is more liable to explode and ignite. Such areas that you would see this as in mines when they're looking for those substances. So that's where a good area to have this EMS would be. So for the sensor that we acquired would be the MQ-4 gas sensor. It's a low-cost sensor from the Winson electronic company, and it's highly sensitive to methane, so it's able to pick it up pretty easily with no problem. It is also compatible with LabVIEW, which would be the main programming instrument that we'd be using for that. Its detection range is between 300 to 10,000 particles per million, and the voltage requirement is 5 volts at the max, either AC or DC. So next, now this is the flow chart, which is mainly the way the program would read. First off, we would start with an on and off switch just to start the system, which would activate the fan, which would draw air into the EMS. It would be placed in areas that it would have the need for it. So this is just to help to get the particles in there, so to sense it properly. The analog in would most likely be the sensor, so then it would get that information, and through our program it would calculate the concentration at which it would let us know depending on the LED lights. So first off, we'll be starting with the green LED. It'll be programmed to start registering between the 300 parts per million. So that would just be green. So then nothing would be arise. And once you start getting into the yellow LED with pin 19, that'd be roughly 350 particles per million. And then you can also see that the voltage is also increased. Once it starts getting closer to 400 particles per million, that's where the red LED will light, and then the speaker will also activate, letting anyone in the vicinity know that the levels of methane in the area are becoming too high for explosions to occur, and that's where it would keep on going.